So go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone's finished, you can unpause it, and I will show you how to work both of them. So this is going to be factored. First off, you need to remove your 4. And we will replace our 4. And the numbers that you're going to use are -25 and -36. And then both of those will be factored further because they're both differences of squares. That would be how 4x to the 4th minus 25 factors. And then we would have 2x squared minus 6 and 2x squared plus 6. So this would be your answer for the factoring. Now for the math knowledge question, it asks for the length along the base. So that's looking here. What is that value right there? Well, we're going to use our trig functions, and we're going to use the cosine of angle 75. It's going to be x over 10 because it's adjacent over hypotenuse. Multiply by 10, and you end up with b for your answer, 10 cosine of 75. So that's how you work both of those two. Moving on to lesson 78, we're looking at particle motion, part 1. These are acceleration, velocity, position functions, but they are not necessarily going to be objects that are on Earth's surface. So they're not going to have an acceleration of -9.8 or -9.81 or positive 9.8 or positive 9.81. These are just random particles. They have made them up for you to be able to practice the concepts that go along with particle motion. So hopefully you'll understand how to deal with particle motion after we finish this lesson. So for this example, we have a particle moving along the x-axis, and they tell us our acceleration is given as 3t. Again, it's not going to be 9.8 or 9.81 or negative one of those. They tell us the velocity when the time is 0 is -10, and the position when time equals 0 is 6. We want to find the position equation, and then they ask what is the position when t equals 2. So we're going to start with our acceleration function, and we can integrate that, and if we integrate it, we get the velocity function. So you have 3 over 2 t squared plus c. Now, when the time is 0, our velocity is -10. That's what they told us right here. So when we plug in a 0 for our t, we end up with a -10. So that means that our c is actually a -10. So this would be our velocity function, 3/2 t squared minus 10. And I'm going to box it just so that we can see it easily later. So that's your velocity function. Now to find the position function, we're going to integrate that. So if you integrate your 3/2 p to the 2, you end up with 1/2 t cubed minus 10t, and then plus c. Now to figure out what our c is, they told us when time is 0, the position is 6. So 6 equals 1/2 0 cubed minus 10 0 plus c. So that means that our 6 equals c. So our position function is given as 1/2 t cubed minus 10t plus 6. And so that's what it asks for. Find the equation that describes the position. So there it is. And then it asks, what is the position when t equals 2? Well, to find that, you're going to do x of 2. So that's going to be 1/2 t cubed minus 10t plus 6. And so if you plug that in, you're going to end up getting a -10. And so that's your position when your time is equal to 2. Looking at the next example, we have a particle that's moving along the x-axis such that the acceleration is -3t. The position when t equals 3 is 20, and its velocity at t equals 1 is 5. We want to know what is the position when t equals 4 And at what time is the particle changing direction? So again, we're going to start with our acceleration function. So our acceleration function here is negative 3t. You integrate that to get your velocity function. So we have negative 3 over 2 t squared plus c. When our t is 3, our velocity, no, when our t is 1, our velocity is 5. So 5 equals negative 3 over 2, 1 squared plus c. So you actually have to do a little bit of work here to find your c. You can't just make it equal to whatever number that was. So we have 5 equals negative 3 over 2 plus c. So 5 plus 3 halves is going to be 13 halves. And so that's what your c value is. So our velocity function is negative 3 over 2 t squared plus 13 over 2. Okay? So now you got to find the position function. So you're going to integrate your velocity to get your position. So if you integrate negative 3 halves t squared, you end up with negative 1 half t cubed, and then plus 13 over 2 t plus c. And so now the position when t equals 3 is 20. So we have 20 equals negative 1 half 3 cubed plus 13 over 2, 3, and then plus c. So again, you got to do a little bit more work than you did on the last example. 3 cubed is 27. And then 13 times 3 is 39. So negative 27 plus 39. And if you divide that by 2, you get 6. So your c value should be 14. Okay, so I'm going to extend the page. We'll have our position function as negative 1 half t cubed plus 13 over 2 t, and then plus 14. So there's your position function. So it asks, what is the position when t equals 4? Well, to find the position when t equals 4, you're just going to plug in a 4 for your time. And so if you plug that in, 4 cubed is 64 times 1 half, so negative 32. And then 13 times 2, basically 26, and then plus 14. You should get a position of 8 when your time equals 4. So that would be part of your answer. And then it says, at what time is the particle changing direction? Well, that only happens when the velocity equals 0. So we go to our velocity function, and we set it equal to 0. And so I'm going to add my 3t squared, multiply by the reciprocal. Those 2's will cancel, and I have 13 over 3 is equal to t squared. So take the square root. So your time is going to be plus or minus the square root of 13 over 3. And that is how they leave the answer. They don't actually make it the square root of 39 over 3 like you would have expected them to. They leave it just like that. You do have to have this plus or minus. We're not dealing with real particles, so you do need to leave the plus or minus there. If we were dealing with a physics question, or we had an actual object, then we wouldn't need the plus or minus. But since it's just some random particle, we're going to leave the plus or minus in our answer. Moving on to the next example. We have a particle moving along the x-axis, so that the velocity at time t is given by this function 1 over t, as long as t is greater than 0. And the position is 5 when t equals 2. We want to find when the particle is 10 units to the right of the origin. So the first thing that we need to do is to figure out the position. So our position function is going to be to integrate 1 over t. If you integrate that, you get the ln of t plus c. So the position is 5 when our time is 2. So that means that 5 minus the ln of 2 is our c value. So our position function is given by ln of t and then plus 5 minus the ln of 2. Okay? Now, to figure out when the particle is 10 units to the right of the origin, we're going to let our position be a 10, and we're going to solve for our t. So I can go ahead and move these two terms over to the left, and I have 5 plus the ln of 2 equals ln of t. I can then use my log rules and rewrite this as t equals e to the 5 plus ln of 2. Which you can also write as 2e to the 5th, which is approximately 296.8263. And so that would be when the particle is 10 units to the right, because that's the position. It said the position was a 10, and so that's what you would do there. So again, these particles are not real life particles. They're just made up. It's just giving us practice with position, velocity, and acceleration questions. So that's all that these are dealing with. So you do get to omit number 8 on your homework tonight. Make sure you do that so that we can go over the questions that you have tomorrow.